Welcome. Yeah, cool. So this is part 16, I believe. Yeah, intro to rates. So part 15, last thing I did was the first quiz, and now, yeah, let's just continue.
What I want to explore in this video is the notion of a rate. So let's look at some examples of rates that you've probably encountered in your everyday life. So if you're driving in your car down the road and you're looking at the speedometer, you might see that it says that you are going 35 mph, where the mph stands for 35 miles per hour. Well, what's that saying? That's saying, well, every hour, how many miles are you going if you were to stay at that current rate? So it could be a measure of speed. How much distance are you covering per unit time? And most typically when people talk about rates, that's what they're talking about. They're talking about how much of something that is happening per unit time. And it doesn't have to be even distance per unit time. You might have your hourly rate for someone who's doing some type of a job. They might say that they're making $10. So they're making $10, and actually, let me write the dollars out so the units become a little bit more obvious. $10 per hour, dollars per hour. And so once again, this is how much money. It's not talking about distance anymore. How much money is being earned per unit time. And so even though rates are often associated with how much something is happening per some unit time, and it could be miles per hour, or it could be meters per second, or in this case, it could be your wage, it could be dollars per hour, rates don't have to be just in those terms. In fact, you might say, all right, I have a dessert that I really enjoy, but I'm very conscientious about the number of calories that I consume. And you might see something like there are 200 calories per serving. And so this is telling us the number of calories per serving. And they'll tell us what a serving is. A serving might be a cup or 8 ounces or whatever else. And so I could say, okay, look, if I have 2 servings, then I'm going to have 400 calories. Same way if I work 2 hours, I'm going to have $20. If I go 2 hours, I'm going to go 70 miles. So rates give you a sense. It's like how fast is something happening, or how much of one thing is happening for every time something else happens. Now I can write rates so they look an awful lot like a ratio. And these words are actually very related because you see that even how they're written. RAT. Their roots are coming from the exact same idea. In fact, this rate over here, 35 miles per hour, it could come from, hey, I just went 35 miles in 1 hour. What's the ratio? So the ratio
5 to 1.
of miles to hours. And then you could say, well, if I went 35, it's the ratio of miles to hours was 35 to 1. Or it could have been, maybe it was 70 to 2 or something like that, but that could have been reduced to 35 to 1. So as a ratio, you would typically see it written like this, or maybe see it written like this. And sometimes you might even see it written like this, 35 miles to 1 hour. But now it's starting to resemble more of the special case of a ratio, which we call a rate, because this is the same thing as 35. Instead of writing it out miles per hour, you'll often see it written like this, miles per hour. So these are very, very related ideas. If you find the ratio between calories and servings, well, then you're going to be able to write, you are going to be able to express it as a rate, and vice versa. Now, why do we care about rates? Well, especially if we're thinking about things like speed, without rates, it'd be hard to quantify how fast things are happening. Otherwise, we'd be in a world where we're saying, hey, I'm faster than you, or she's faster than me, but we wouldn't be able to quantify exactly how fast they are. But with rates, we can say, hey, that person ran 100 meters in 10 seconds. They run 10 meters per second. We can quantify exactly how fast that thing is happening, the rate at which it is happening. Here, instead of saying, hey, hey, a cup of that is going to give you give you more energy, or be, or maybe contribute more to your weight than a cup of that, and making these relative comparisons. Here you can actually quantify things. And when we study rate, we're going to study rate a lot in mathematics. It's going to be essential in algebra when we look at the rate of change of a line, how far it moves in the vertical direction relative to the horizontal direction. We're going to call that slope. And you can even imagine a slope of a hill is kind of how fast is it climbing for as much as you move forward. But we're also going to study rates in detail when we go to calculus. In fact, the whole basis of differential calculus that you might see later in high school and early college is all about measuring instantaneous rate. How fast is something going right now? So rates are really, really interesting, really, really important. And I would guess that if you just look around your life, even over the next few hours, you're going to encounter many, many, many rates.
Cool. Okay. Shit, it's a lot of video. A lot of videos.
Jada takes 3 hours to deliver 189 newspapers on her paper route. What is the rate per hour? The rate per hour at which she delivers the newspaper. So this Jada takes 3 hours to deliver 189 newspapers on her paper route. What is the rate per hour? The rate per hour at which she delivers the newspaper. So this first
63.
sentence tells us that she delivers, or she takes 3 hours to deliver 189 newspapers. So you have 3 hours for every 189 newspapers. That's what the first sentence told us. But we want to figure out the rate per hour, or the newspapers per hour. So we can really just flip this rate right here. So if we were to just flip it, we would have 189 newspapers for every 3 hours. For every 3 hours. Which is really the same information. We're just flipping what's in the numerator and what's in the denominator. Now, we want to write it in as simple as possible form. And let's see if this top number is divisible by 3. 1 plus 8 is 9. Plus 9 is 18. So that is divisible by 3. So let's divide this numerator and this denominator by 3 to simplify things. So if you divide 189 by 3, let's do it over the side, over on the side right here. 3 goes into 189. 3 goes into 18 6 times. 6 times 3 is 18. Subtract. Bring down the 9. 18 minus 18 was nothing. 3 goes into 9 exactly 3 times. 3 times 3 is 9. No remainder. So if you divide 189 by 3, you get 63. And if you divide 3 by 3, you're going to get 1. You have to divide both the numerator and the denominator by the same number. So now we have 63 newspapers for every 1 hour. Or we could write this as 63 over 1 newspapers per hour. So we could write this as 63 over 1 newspapers per hour, per 1 hour. Or we could write this as 63, because 63 over 1 is the same thing as 63. 63 newspapers per hour. Miranda's maid service charges $280 to clean 8 offices. What is the company's price for cleaning a single office? So they charge $280. So they charge 280, I'll write it out, dollars, $280 to clean 8 offices. So it's $280 per every 8 offices. $280 for every 8 offices. And then we can simplify this. We could see, well, are both of them divisible by a common factor? And this one looks like it is divisible by 8. 200 is divisible by 8, and then 80 is divisible by 8 as well. So let's divide both the numerator and the denominator by 8. And if we do that, 8 goes into 280. 8 goes into 28 3 times. 3 times 8 is 24. subtract. You have 4 left over. 8 minus 4 is 4. Bring down this 0. 8 goes into 40 exactly 5 times. 5 times 8 is 40, and you have no remainder. So when you divide 280 by 8, you get 35. And if you divide 8 by 8, you get 1. So this rate simplifies to, this price per office, I guess we could call it, simplifies to $35
dollars per office.
for every one office, which we could also write as 35 over 1 dollars per office, which is the exact same thing as 35 dollars per office. And we're done. That is the company's price for cleaning a single office, $35.
5 days you got 30 gigs. France can complete 91 oil changes in 7 days. Wait, what? 91 at 7 times 13, right? 70, 21. In 11 days. Oh, crap, 11 days. I thought, wait, what? Oh shit, 7 days. Okay, so let's see. Uh, so that's like 13 per day. Yeah, cool. The market 5 light bulbs costs okay 98. And you can write Oh shit. Wait, what? No way. Insane. Okay. Oh shit, in 8 hours. Oh fuck, I made a mistake. It's actually in 8 hours. What? Okay. They're 1.75. If you divide like, oh shit, 5.14. 63. Oh shit, why did it say 63? It's actually 56. 60. 8. 4. Just 14.
Starting at home, Umama traveled uphill to the gift store for 45 minutes at just 8 miles per hour. She then traveled back home along the same path downhill at a speed of 24 miles per hour. What is
Marriage and going.
Hello.
her average speed for the entire trip from home to the gift store and back? So we're trying to figure out her average speed for the entire trip. That's going to be equal to the total distance that she traveled over the total time. Over the total time. Total time. Well, what's the total distance going to be? Well, the total distance is going to be the distance to the gift store and then the distance back from the gift store, which are the same distances. So it's really, you could say, 2 times the distance to the gift store. So 2 times the distance to the gift store. To the gift store. And then what is going to be her total time? Well, it's time to the gift store. So it's time to gift store, and then plus the time coming back. Time coming back from the gift store. Now, we know that the distance to the gift store and the distance back from the gift store is the same. So that's why I just said that the total distance is just going to be 2 times the distance to the gift store. We don't know. In fact, we know we're going to have different times in terms of times to the gift store and times coming back. How do I know that? Well, she went at different speeds. So it's going to take her, actually, she went there much slower than she came back. So it would take her longer to get there than it took her to get back. So let's see which of these we already know. So how do we figure out the distance to the gift store? No point here do they say, hey, the gift store is this far away. But they do tell us, this first sentence right over here, Umama traveled uphill to the gift store for 45 minutes at just 8 miles at just 8 miles per hour. So we're given a time and we're given a speed, we should be able to figure out a distance. So let's just do a little bit of a side here. We should be able to figure out the distance to the distance. Actually, let me write it this way. Distance to the store. Distance to store will be equal to, and we got to make sure we have our units right. Here they gave it in minutes. Here they have 8 miles per hour. So let's convert this into hours. So 45 minutes in hours So it's 45 minutes out of 60 minutes per hour. So that's going to give us 45 sixtieths, divide both by 15. That's the same thing as 3/4. So it's going to be 3/4 hours. 3/4 hours is 45 sixtieths, divide both by 15 per hour. So that's going to give us 45 sixtieths, divide both by 15. That's the same thing as 3/4. So it's going to be 3/4 hours. 3/4 hours is the time times an average speed of 8 miles per hour times 8 miles per hour. So what is the distance to the store? Well, 3/4 times 8, or you could view it as 3/4 times 8 times 1, is going to be, what's going to be 24 over 4. Let me just write that. That's going to be 24 over 4, which is equal to, did I get, yeah, 24 over 4, which is equal to 6. And units wise, we're just left with miles. So the distance to the store is 6 miles. 2 times the distance to the gift store, well, this whole thing is going to be 12 miles. 12 miles is the total distance she traveled. Now, what is the time to the gift store? Well, they already told that to us. They already told us that it's 45 minutes. Now, I want to put everything in hours. I'm assuming that they want our average speed in hours, so I'm going to put everything in hours. So the time to the gift store was 3/4 of an hour. 3/4 hours. And what's the time coming back from the gift store? Well, we know her speed. We know her speed coming back. We already know the distance from the gift store. It's the same as the distance to the gift store. So we can take this distance. We can take 6 miles. That's the distance to the gift store. 6 miles divided by her speed coming back, which is 24 miles per hour. So divided by 24 miles per hour gives us, let's see, we're going to have 6 over 24 is the same thing as 1/4. It's going to be 1/4. And then miles divided by miles per hour is the same thing as miles times hours per mile. The miles cancel out, and you'll have 1/4 of an hour. So it takes her 1/4 of an hour to get back, and that fits our intuition. Actually, let me write that in the same green color since I'm writing all the times in colors, in green color. So 1/4 of an hour. So she went there. Going to the gift store was slow, took her 3/4 of an hour. Coming back only took her 1/4 of an hour. 1/4 of an hour. So now we're ready to calculate her average speed for the entire trip. Her average speed for the entire trip is going to be equal to the total distance, which is 12 miles. 12 miles divided by her total time. 3/4 hours plus 1/4 hour is exactly 1 hour. So her average speed is 12 over 1, which is just 12 miles per hour. Her average speed is just 12 miles per hour. And you might have been tempted to say, hey, wait, why don't I just average 24 and 8? But that wouldn't have been right because she's traveling those for different amounts of time. So what you really have to do is just think in terms of go back to your basics, total distance, total time. Figure out the total distance. This first sentence right over here gives us half of the total distance, the time to the store. We just double that to get the time back. And then our total time we can figure out. They tell us the time to the store, and then we can figure out the distance from the store and using that and the velocity and the speed to figure out her time. Time back. And then we get total distance divided by total time, 12 miles per hour. Let's get some practice comparing and computing rates. Starting at home, Umama traveled uphill to the gift store for 45 minutes. So they tell us the pet store has 8 miles per hour.
This is significantly much harder than the previous ones.
has three. Let's get some practice comparing and computing rates. So they tell us the pet store has 3 fish tanks, each holding a different volume of water and a different number of fish. So tank A has 5 fish and it has 40 liters of water. Tank B, 12 fish, 100 liters of water. And tank C, 23 fish and has 180 liters of water. Order the tanks by volume per fish from least to greatest. So let's think about what volume per fish. And we could think about this as volume divided by fish. Volume per fish. All right, so here for tank A, it's going to be 40 liters for every 5 fish. 40 for every 5 fish. And let's see, 40 over 5 is 8. So you have 8 liters per fish is the rate at which they have to add water per fish for tank A. Now, tank B, you have 100 liters for 12 fish. So what is this going to be? This is going to be 12 goes into 100 8 times. So 8 times 12 is 96. And then you have 4 left over. So this is going to be 8 and 4 twelfths, or 8 and 1/3 liters per fish. And all I did is I converted this improper fraction, 100 over 12, to a mixed number, and I simplified it. 12 goes into 100 8 times with the remainder 4. So it's 8 and 4 twelfths, which is the same thing as 8 and 1/3. And then finally, in tank C, I have 180 liters for 23 fish. So what is this going to be? 23 goes into 180. Let me actually try to calculate this. 23 goes into 180. It looks like it's going to be less than 9 times. Is it 8 times? 8 times. No, not 8 times. Let's see, 7 times. 7 times 3 is 21. 7 times 2 is 14. Plus 2 is 16. When you subtract, you get a remainder of 19. So this is going to be 7 with remainder is 8 times. No, not 8 times. Let's see, 7 times. 7 times 3 is 21. 7 times 2 is 14. Plus 2 is 16. When you subtract, you get a remainder of 19. So this is going to be 7 with remainder 19, or you could say this is 7 and 19/23 liters per fish. So which one has, we're going to order the tanks by volume per fish from least to greatest. So tank B has the largest volume per fish, has 8 and 1/3 liters per fish. So this is in first place. And then tank A is in second place. Tank A is in second place. And then tank C is in third place. Oh, actually, we want to go from least to greatest. So this is, let me write it this way. This is tank C is the least, and tank A is the greatest. Greatest. So we really have to swap this order around. Now, I just copied and pasted this from the Khan Academy exercises. Let me actually bring the actual exercise up, and I can rearrange it. C was the least, and B was the most. And we check our answer, and we got it right.
What? Yeah, cool. Actually correct.
Least, let me actually bring the actual exercise up,
B.
and I can rearrange it. C was the least, B was the most. And we check our answer, and we got it right. I have some footage here of one of the most exciting moments in sports history. And to make it even more exciting, the commentator is speaking in German. And I'm assuming that this is okay under fair use because I'm really using it for a math problem. But I want you to watch this video and then I'll ask you a question about it.
Set. Paul ist der schnellste aus den Blöcken. Jetzt kommt G. Und jetzt ist Usain Bolt nicht zu halten. Nein, er gewinnt. 9,58 Weltrekord. Ein Wahnsinn.
So you see, it's exciting in any language that you might watch it. But my question to you is, how fast was Usain Bolt going? What was his average speed when he ran that 100 meters right there? And I encourage you to watch the video as many times as you need to do it. And now I'll give you a little bit of time to think about it, and then we will solve it. So we needed to figure out how fast was Usain Bolt going over the 100 meters. So we're really thinking about, in the case of this problem, average speed or average rate. And you might already be familiar with the notion that distance is equal to rate or speed. I'll just write rate times time. And I could write times like that. But once we start doing algebra, the traditional multiplication symbol can seem very confusing because it looks just like the variable x. So instead, I will write times like this. So distance is equal to rate times time. And hopefully this makes some intuitive sense for you. If your rate or your speed were 10 meters per second, just as an example, that's not necessarily how fast he went, but if you went 10 meters per second, and if you were to do that for 2 seconds, then it should hopefully make intuitive sense that you went 20 meters. You went 10 meters per second for 2 seconds. And it also works out mathematically. 10 times 2 is equal to 20. And then you have seconds in the denominator and seconds up here in the numerator. I just wrote seconds here with an S. I wrote it out there. But they also cancel out, and you're just left with the units of meters. So you're just left with 20 meters. So hopefully this makes intuitive sense. With that out of the way, let's actually think about the problem at hand. What information do we actually have? So do we have the distance? So what is the distance in the video we just did? And I'll give you a second or two to think about it. Well, this race was 100 meters, so the distance was 100 meters. Now, what else do we know? Well, we're trying to figure out the rate. That's what we're going to figure out. What else do we know out of this expression, out of this equation right over here? Well, do we know the time? What was the time that it took Usain Bolt to run the 100 meters? And I'll give you another few seconds to think about that. Well, luckily they were timing the whole thing, and they also show that it's a world record. But this right over here is in seconds. It's how long it took Usain Bolt to run the 100 meters. It was 9.58 seconds, and I'll just write S for seconds. So given this information here, what you need to attempt to do is now give us our rate in terms of meters per second. I want you to think if you can figure out the rate in terms of meters per second. We know the distance and we know the time. Well, let's substitute these values into this equation right over here. We know the distance is 100 meters. The distance is 100 meters. And it's equal to, we don't know the rate, so I'll just write rate right over here. And let me write in that same color. It's equal to rate times, and what's the time? We do know the time. It's 9.58 seconds. 9.58 seconds. And we care about rate. We care about solving for rate. So how can we do that? Well, if you look at this right-hand side of the equation, I have 9.58 seconds times rate. If I were able to divide this right-hand side by 9.58 seconds, I'll just have rate on the right-hand side, and that's what I want to solve for. So you say, well, wait, why don't I just divide the right-hand side by 9.58 seconds? 9.58 seconds. Because if I did that, if the units cancel out, if we're doing dimensional analysis, don't worry too much if that word doesn't make sense to you, but the units cancel out and the 9.58 cancel out. But I can't just divide one side of an equation by a number. When we started off, this is equal to this up here. If I divide the right side by 9.58, in order for the equality to still be true, I need to divide the left side by the same thing. So I can't just divide the right side, I have to divide the left side in order for the equality to still be true. If I said one thing is equal to another thing and I divide the other thing by something, in order for them to still be equal, I have to divide the first thing by that same amount. So I divide by 9.58 seconds. So on our right-hand side, and this was the whole point, these two cancel out. And then on the left-hand side, I'm left with 100 divided by 9.58. And my units are meters per second, which are the exact units that I want for rate or for speed. And so let's get the calculator out to divide 100 by 9.58. So I've got 100 meters divided by 9.58 seconds gives me 10.0 let's say we get about 3 significant digits here. So let's say 10.4. So this gives us 10.4. And I'll write in the rate color. 10.4. And the units are meters per second. Meters per second is equal to my rate. Now the next question, so we got this in meters per second, but unfortunately meters per second they're not the, when we drive a car, we don't see the speedometer in meters per second. We see the either kilometers per hour or miles per hour. So the next task I have for you is to express this speed or this rate. And this is his average speed or his average rate over the 100 meters. But to think about this in terms of kilometers per hour. So try to figure out if you can rewrite this in kilometers per hour. Well, let's just take this step by step. So I'm going to write, so let me just go down here, start over. So I started off with 10.4, and I'll write meters in blue, and seconds in magenta. Now, we want to get to kilometers per hour. Right now we're at meters per second. So let's take baby steps. Let's first think about it in terms of kilometers per second. And I'll give you a second to think about what we would do to this to turn this into kilometers per second. Well, the intuition here, if I'm going 10.4 meters per second, how many kilometers is 10.4 meters? Well, a kilometers is a much larger unit of measurement. It's 1,000 times larger. So 10.4 meters will be a much smaller number of kilometers. And in particular, I'm going to divide by 1,000. Another way to think about it, if you want to focus on the units, we want to get rid of this meters and we want a kilometers. So we want a kilometers and we want to get rid of these meters. So if we had a meters in the numerator, we could divide by meters here and they would cancel out. But the intuitive way to think about it is we're going from a smaller unit, meters, to a larger unit, kilometers. So 10.4 meters are going to be a much smaller number of kilometers. But if we look at it this way, how many meters are in 1 kilometer? 1 kilometer is equal to 1,000 meters. This right over here, 1 kilometer over 1,000 meters, this is over 1 over 1. We're not changing the fundamental value. We're essentially just multiplying it by 1. But when we do this, what do we get? Well, the meters cancel out. We're left with kilometers and seconds. And then the numbers, you get 10.4 divided by 1,000. 10.4 divided by 1,000 is going to give you, so if you divide by 10, you're going to get 1.04. You divide by 100, you get 0.104. You divide by 1,000, you get 0.0104. So that's just 10.4 divided by 1,000. And then our units are kilometers per second. So that's the kilometers, and then I have my seconds right over here. Now, so let me write the equal sign. Now let's try to convert this to kilometers per hour, and I'll give you a little bit of time to think about that one. Well, hours, there's 3,600 seconds in an hour. So however many kilometers I do in a second, I'm going to do 3,600 times that in an hour. And the units will also work out. If I'm going, right now, well, if I do this many in a second, so it's going to be times 3,600. There are 3,600 seconds in an hour. 3,600 seconds in an hour. And another way to think about it is we want hours in the denominator. We had seconds. So if we multiply by seconds per hour, there are 3,600 seconds per hour. The seconds are going to cancel out, and we're going to be left with hours in the denominator. So seconds cancel out, and we're left with kilometers per hour. But now we have to multiply this number times 3,600. I'll get the calculator out for that. So we have 0.0104. 0.0104.
No, let me answer it. So
times 3,600.
37.44
gives us 37 point,
hour.
I'll just say 37.4. So this is equal to 37.4 kilometers per hour. Kilometers per hour.
got
So
same
that's
shit.
his average speed in kilometers per hour. And now the last thing I want to do for those of us in America, we'll convert into imperial units, or sometimes called English units, which are ironically not necessarily used in the UK. They tend to be used in America. So let's convert this into miles per hour. And the one thing I will tell you, just in case you don't know, is that their 1.61 kilometers is equal to 1 mile. So I'll give you a little bit of time to convert this into miles per hour.
Wow.
Well, as you see from this, a mile is a slightly larger or a reasonably larger unit than a kilometer. So if you're going 37.4 kilometers in a certain amount of time, you're going to go a slightly smaller amount of miles in a certain amount of time. Or in particular, you're going to divide by 1.61. Cool. So let me rewrite it. If I have 37.4 kilometers per hour, we're going to a larger unit. We're going to miles. So we're going to divide by something larger than 1. So we have 1, let me write it in blue. 1 mile is equal to 1.61 kilometers. Or you could say there's 1.61 mile per kilometer. And it also, once again, works out with units. We want to get rid of the kilometers in the numerator, so we would want it in the denominator, and we want a mile in the numerator, so that's why we have a mile in the numerator here. So let's once again multiply, or I guess in this case we're dividing by 1.61, and we get, let's just divide our previous value by 1.61, and we get 23 I'll just round up, 23.3. This is equal to 23.3, and then we have miles per hour. Miles per hour, which is obviously very fast. He's the fastest human, but it's not maybe as fast as you might have imagined. You know, in a car, 23.3 miles per hour doesn't seem so fast, and especially relative to the animal world, it's not particularly noteworthy. This is actually slightly slower than a charging elephant. Charging elephants have been clocked at 25 miles per hour.
Holy shit.
I have some footage here of one of the most exciting moments in sports history. And to make it even more exciting, the commentator She then traveled.
Welcome to the presentation on units. Let's get started. So if I were to tell you, let me make sure my pen is set up right. If I were to tell you that someone is, let's say they're driving at a speed, let's say it's Zach. Where's my pen go? Oh, I'm using the wrong tool. Okay. So let's say I had Zach. And they're driving at a speed of, let me say, 28 feet per minute. So what I'm going to ask you is, if he's going 28 feet in every minute, how many inches will Zach travel in 1 second? So how many inches per second is he going to be going? Let's try to figure this one out. So let's say if I had 28, and I'll write FT short for feet. Feet per minute, and I'll write min short for minutes. So 28 feet per minute. Let's first figure out how many inches per minute that is. Well, we know that there are 12 inches per foot, right?
I'm gonna solve this
You didn't
on my own. But so let's go now. So yeah. So we have like 3.76 or 3.77 inches per second. I don't know, that's what I got.
You didn't know that, you do now. So we know that there are 12 inches per foot. So if he's going 28 feet per minute, he's going to be going 12 times that many inches per minute. So 12 times 28.
I got
Work
3.77
down here. 28
inches
12.
per second.
16, 56, 280. I probably shouldn't be doing it this messy. And this kind of stuff, it'd be okay to use a calculator, although it's always good to do the math yourself. It's good practice. So that's 6, 5 plus 8 is 13, 336. So that equals 336 inches per minute.
Oh yeah, is that what I got? Yeah.
And something interesting happened here is that you notice that I had a foot in the numerator
divide
here,
by
and I had
60
a
and
foot
you
in the
get inches
denominator
per
here. So you can actually treat units just the same way that you would treat actual numbers or variables. If you have the same number in the numerator and you have the same number in the denominator, and you're multiplying, not adding, you can cancel them out. So the feet and the feet canceled out, and that's why we were left with inches per minute.
Cool.
I could have also written this as 336 foot per minute times inches, that's inches per foot. And because the foot per minute came from here, and inches per foot came from here. And then I would have canceled this out, and I would have gotten inches per minute. So anyway, I don't want to confuse you too much with all of that unit cancellation stuff. The bottom line is you just have to remember, well, if I'm going 28 feet per minute, I'm going to go 12 times that many inches per minute, right? Because there are 12 inches per foot. So I'm going 336 inches per minute. So now I have the question, but we're not done, because the question is how many inches am I going to be traveling in 1 second? So let me erase some of the stuff here at the bottom. Let me erase this, because that's probably just going to confuse everybody. Actually, I'll erase this too.
This is oddly relaxing, like ASMR version of
So I'm going to be going
I'm gonna sleep as well.
336 inches. Let's write like that.
Oh shit! Divided by
Inches
60.
per minute. And I want to know how many inches per second. Well, what do we know? We know that 1 minute And notice, I write it in the numerator here because I want to cancel it out with this minute here. 1 minute is equal to how many seconds? It equals 60 seconds. Right? And just this part can be confusing, but it is always good to just take a step back and think about what I'm doing. If I'm going to be going 336 inches per minute, how many inches am I going to travel in 1 second? Am I going to travel more than 336, or am I going to travel less than 336 inches per second? Well, obviously less, because a second is a much shorter period of time. So if I'm in a much shorter period of time, I'm going to be traveling a much shorter distance if I'm going the same speed. So I should be dividing by a number, which makes sense. I'm going to be dividing by 60. And I know this can be very confusing in the beginning, but that's why I always want you to think about, should I be getting a larger number, or should I be getting a smaller number? And that'll always give you a good reality check. And if you just want to look at it, how it turns out in terms of units, we know from the problem that we want this minutes to cancel out with something and get into seconds.
Yeah.
So if we have a minutes in the denominator in the units here, we want a minutes in the numerator here, and a seconds in the denominator here. And 1 minute is equal to 60 seconds.
That is true.
So here,
that is true.
once again, the minutes and the minutes cancel out, and we get 336 over 60 inches per second. Excuse me. And now if I were to actually divide this out,
oh shit, why did I mention that?
we could see, actually we could just divide the numerator and the denominator by 6. 6 goes into 336, what, 56 times? 56 over 10. And look, we could divide that again by 2. So then that gets us 28 over 5. And 28 over 5, let's see, 5.
Yo, that's insane.
Goes into 28, 5 times 25, 3, 5.6.
I got 5.6, I got 3.7.
5.6.
Could be my division up
I
here.
think we now just solved the problem. If Zach is going 28 feet in every minute, that's his speed, he's actually going 5.6 inches per second. Hopefully that kind of made sense. Let's try to see if we can do another one.
Oh shit, it makes sense.
If I'm going 91 feet per second.
Wow, okay. Why did I write 3? That's messed up. It's only 180. Oh my god.
Second. How many miles per hour is that? Well, 91 feet per second. So how many, if we want to say how many miles that is, should we be dividing or should we be multiplying? Well, we should be dividing because it's going to be a smaller number of miles. And we know that that 1 mile is equal to, and you might want to just memorize this, 5,280 feet. It's actually a pretty useful number to know. And then that will actually cancel out the feet. And then we want to go from seconds to hours, right? So if we go from seconds to hours, if I can travel 91 feet per second, how many will I travel in an hour? I'm going to be getting a larger number because an hour is a much larger period of time than a second. And how many seconds are there in an hour? Well, there are 3,600 seconds in an hour. 60 seconds per minute and 60 minutes per hour. So 3,600 over 1 seconds per hour. And these seconds will cancel out. And then we're just left with, we just multiply everything out. We get, in the numerator, 91 times 3,600, right? 91 times 1 times 3,600. In the denominator, we just have 5,280. And this time around, I'm actually going to use a calculator. I'm going to bring up the calculator just to show you that I'm using a calculator. Let's see. So if I say 91 times 3600, whoops, messed up. 91 times 3600, that equals a huge number, divided by 5,280. Oh man, I keep messing up. 91 times 3600 divided by 5,200. This calculator, I think my mouse is messed up. Let me see if I can type it. 91 times 3600
This
divided by
this mouse is double clicking.
62.05. So that equals 62.05 miles per hour. Welcome to the presentation.
2007, holy shit. Oh shit, oh my god, this is actually 4. I'm really out of my mind again. I already made a mistake at the first attempt. Holy shit. Following table shows the cost of poor party. Should really double check everything again before submitting. I'm supposed to do it like this, right? And then divide it. Oh my god, can I just use a calculator? It's gonna be the beach ball. Am I allowed to do this? I don't know. Can I use calculator in Khan Academy? Crap, so it's yo-yo. I should just probably do it again. So this is 2. 15, speed 2.5, correct. Okay, okay. I don't know, I shouldn't use calculator, I guess. Then they bought a set of 20 markers for 1 marker. Should I just say calculator? I don't know. Am I allowed to use a calculator? Fucking no. Maybe not. We got 3. No, not 2. Oh yeah, 2. 220. So it's like 3 again. But what? This is insane. This is just repeating shit. Am I supposed? Oh my god. Yeah. I'm not supposed to write that it's an infinite shit. How do I write that? I don't know. Since I already made one mistake, maybe. Fuck? Supposed to round this off? Oh shit, it's actually the other way around. Okay, I could be just so bored. Or my back hurts. I don't know. She burns 756 calories while driving for 3 hours. She burns the same number of calories for each hour. How many calories does VB burn per hour? Alright, so we just have 756 divided by 3. It's gonna give us your thing per hour. Alright, 252 calories. Following table shows the number of heartbeats for animals. 65 per minute. Okay, oh my gosh, how do they divide all of this? Let's see which the closest. Let's see. Actually, I don't need to, let's just go like 65. What's the multiple of this? As we go everywhere. So let's see. Multiply that 65 by 3. 15. That's 195. Do I have 195? No, we don't. Okay, so it's already. Nope. 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 65 times 4. We have 20. We have 24. 26. We have 260. Okay, so you know as well. 65 times 8. That could be the dog. 44, 48, 52. Okay, cool. Cow works. Nicola buys a bouquet of 8 sunflowers for 18. What is the cost of 1 sunflower? Actually, we divide that by 8. So we have 2, 16, 20. It's gonna be 2 again. We have 16. 5. Wait, what? 4. 2.25. Sydney read 50 pages in 14 minutes. She reads at a constant. How many pages can Sydney? Per minute. Oh, cool. 50. Or we just do like, it's just 5 over 4. This is 5 divided by 4. What is this? I don't know. My back hurts though. 8. Yo, this is a lot. Oh shit. 5, 4, 1, 4, 1, 10, 1.2, I guess. Oh shit, what? What? 5 divided by 4. One time, we got 4. Yeah, 1, 10. 1.5. Why this is right? 1.2, bitch. Oh no. Wait, what? 1 point. It's not the final answer yet, man. 1.25 pages. I'm sorry. I'm not thinking through enough. Okay. Let's try. Let's not make a mistake this time. Let's not waste our time. Been recording for an hour only. I haven't made any progress. Should make this a bit smaller. Okay. The following table shows how many multiplication problems for students were able to solve in different amounts of time. For example, Murray solved 58 problems in 2 minutes. Wow, that's insanely a lot. 28 per minute. Okay, 28 per minute. Let's see. 28 times 56. No. Let's see. Times 3. 8 times 3 is 4. So no. I think this would work. Or let's see. 28 times 3. Any of these could work. So let's see. 4, 2, 6, 8 to 4. Wow, that worked. Logan works. But let's check for Taylor. So 28 times 4. 2, 3, 8. Doesn't work. Yeah, it's obviously over 100 because 25 times 4 is already 100. Ruben bought 6 comic books for 20. What was the cost for 1 comic book? Okay, so we just have 21 divided by 6. So 3, 18, 3, 30. This is 5. Okay. A roller coaster can take 162 passengers around the track in 9 minutes. The roller coaster operates in a constant rate. How many passengers can the roller coaster? Per minute. You have 9, 3, 32, and then should I just use a calculator? I think I'm allowed to use a calculator. I don't know. That's 50. Then by 5, we have 50 left. Oh my god, I could be wrong. It's definitely 162 divided by 9. Right? Okay. I mean, it's like 162 9 passengers in minutes, and then we need like per minute. No, why do I need to do this bullshit? 7, 9. Oh shit! I actually wrote 3 earlier. That's stupid. Okay, so we actually have 7, and then 72. Then we have like 18 passengers. Please be correct. Oh yeah, thank you. The following table shows the cost for 4 foods. For example, apple costs $5 for 5 pounds. Which type of fruit is cost? Apples. I'm sure about that. Jen buys 4 tires for $27. Let's see. 8's 24. Oh no, it's added to the fuck. That's actual 6 and 4. 3, 32, and we have 8. 68 per tire. Rachel types 162 words in 3 minutes. 162 divided by 3. You have 5, 15, 12, 54 words from him. 4.5 per hour. Okay. So this has to be an even number. This cannot be. Times 4 is 918. So no. So 9 times 3. This works out. This works out. Let's try 4.5 times 8. Oh, it's 40. And 4 36. It's piece by piece, and then I think I'm gonna be back for a minute. And takes 48 minutes for 7 people to paint 7 walls. Wow, this is insane. What the fuck? It takes 48 minutes for 7 people to paint 7 walls. How many minutes does it take? 20 minutes to paint 20 walls. Would this just be the same? Do I need to worry about the walls? I think I should just worry about this shit. For 720, it's not a nice round number though. I'm a bit stalled. So what's a hint? Let's see.
A squirrel is running across the road at 12.
Am I supposed to? Seven people, right? And then for every people, and each, I guess, each one of them can, like 48 per wall. I don't know.
12 feet per second. A squirrel is running across the road at 12 feet per second. It needs to run 9 feet to get across the road. How long will it take the squirrel to run 9 feet? Round to the nearest hundredth of a second, fair enough. A car is 50 feet away from the squirrel. Okay, this is a high stakes word problem. Driving toward it at a speed of 100 feet per second. How long will it take the car to drive 50 feet? Round to the nearest hundredth of a second. Will the squirrel make it 9 feet across the road before the car gets there? So this definitely is high stakes, at least for the squirrel. So let's answer the first question. Let's figure out how long will it take the squirrel to run 9 feet. So let's think about it. The squirrel, let me write squirrel right over here. The squirrel, so the squirrel's got to go 9 feet. And we want to figure out how many seconds it's going to take. So what would we divide or multiply this by 12? Well, to think about that, you could think about the units, where we want to get an answer in terms of seconds. We want to figure out time. So it'd be great if we could multiply this times seconds per foot. Then the feet will cancel out and I'll be left with seconds. Now, right over here, we're told that the squirrel can run at 12 feet per second, but we want seconds per foot. So the squirrel every second, so they go 12 feet per second, then we could also say 1 second per every 12 feet. So let's write it that way. So it's essentially the reciprocal of this because the units are the reciprocal of this. So it's 1 second for every 12 feet. Notice all I did is I took this information right over here, 12 feet per second, and I wrote it as second per foot. 12 feet for every 1 second, 1 second for every 12 feet. What's useful about this is this will now give me the time it takes for the squirrel in seconds. So the feet cancel out with the feet, and I am left with 9 times 1/12, which is 9/12 seconds. And 9/12 seconds is the same thing as 3/4 seconds, which is the same thing as 0.75 seconds for the squirrel to cross the street. Now let's think about the car. So now let's think about the car. And it's the exact same logic. They tell us that the car is 50 feet away. So it's the squirrel is trying to cross the road like that, and the car is 50 feet away coming in like that, and we want to figure out if the squirrel will survive. So the car is 50 feet away. So it's 50 feet away. We want to figure out the time it'll take to travel at 50 feet. Once again, we would want it in seconds, so we would want seconds per feet. So we would want to multiply by seconds per foot. Seconds per foot. They give us the speed in feet per second, 100 feet per second. And so we just have to realize that this is 100 feet for every 1 second, or 1/100th seconds per feet. This is, once again, just this information, but we took the reciprocal of it, because we don't want feet per second, we want seconds per feet. And if we do that, that cancels with that, and we're left with 50 over 100 seconds. So this is 50 over 100 is 0.50 seconds. And so now let's answer the question, this life and death situation for the squirrel. Will the squirrel make it 9 feet across the road before the car gets there? Well, it's going to take the squirrel 0.75 seconds to cross, and it's going to take the car only half a second. So the car is going to get to where the squirrel is crossing before the squirrel has a chance to get all the way across the road. So unfortunately for the squirrel, the answer is no.
Holy shit. I want to see the comments.
A squirrel is running across the road at 12 feet per
But this is so sad. Rip squirrel. Does this number even matter? The 7 walls and 9 walls? Okay, let's try our best to work it out first before doing the hints. 48. I thought this would be the same shit. 20 people do this. Well, let's try it. So we have wow, this is hard. This shit didn't even help me or anything. Yo, I'm stuck at this question. Oh my god, but I don't want to fail the quiz. Let's see. For 7 people to paint 7 walls. What is this freaking ratio? What the hell? How do I even write this? Let's say we have 7 people and then they do like 7 walls for 48 minutes. Ah, 7 walls per 48 minutes. Yo, this is hard. Oh my god, I don't know. This factor right here is messing up my brain. I feel like it would be just the same shit. The 720 was just a distraction. Let's just try to do the 48 divided by 7. Uh, 48 divided by 7. I'll go 6. 48, 4 to 6. 60. 856. 40. Yep. 5. 55. Yeah, so kind of looks like that's not an we ever made. It's a repeating shit. Let's try here. What's 48 divided by 7. Yo, this is hard. What the fuck? How do I approach this shit? Okay, I give up. Let's see. Okay. Damn, man. It's hard. I didn't get any freaking example that uses this. I'm stuck with this shit. Does this even matter? There's 20 walls. Let's think. Yo, this is hard. Yeah, I give up really. This shit's insane. So let's say what by walls? Okay, so if we do one if we make it like one person 48 times 7 would be for one person. What the fuck is this? What the fuck is this? What the fuck is this? Now let's see. If we only have one wall, then the time would be divided by 7. But yo, it's not even. It's repeating shit. See? Would this be the same as 48? I don't know. Fucking bitch. Fucking bitch, man. This is insane. I gave you the hints. Give me the hints. Why that's correct. Yeah, so this 20 wall 7 was a fucking distraction after all. This is insane. It's a fucking trick question. Oh no, this one's we have to do some shit. Okay, let's see. 60 we have 12. So for each person, if we only have one wall, it would take the 7 people 12 minutes to complete it. Seven one. We have 12 minutes per wall. So what the fuck? Now it's 10 people. So what the fuck is this? This is insane, bro. This is insane. Okay. This is fucking insane. Screenshot this. Screenshot this. This is the hardest shit ever. This is harder than calculus or something. Okay, let's see. This is insane, bro. It takes. So we need to figure out the ratio. Oh my god, but this one's 7 to 5 in 60 minutes. This is a multi-level, next level shit. This is messing up my brain. If we divided by 7 and then one man, or one guy, no, not really. Yo, this is so hard. This video doesn't help at all. This squirrel shit in the paint. Let's do 9 divided. Let's do what the guy did. Let's follow what he did. Get out, get out, get out. Let's see what the guy did. So 9 persons, so 7 times the minute, and then divide by the walls. It's 20 people and 5 walls, 10 walls. So we have that guy and 20 people. So we're gonna be left with minutes. So it's gonna be like 7. So what is this? What is this? 60. See. Oh my god, 20 people. 7 divided. Oh my god, do I need a calculator for this shit? Okay, so. No, not really. Only the measurements are gonna cancel out each other. So we have 7 times 60 times 10, or divided by 100. Yo, 420. What the fuck? That's just longer. It's insane. So 60 minutes and 7 people. Over 5 wall. Then we want to cancel out. We want to get the minutes, right? So we have 10 people here. And what the fuck measurement do you use? 10 people, 10 wall. What? Is it supposed to be like that? I don't know. It's insanely hard. Walls persons. And 180 times 3, 540. 540 divided by 7 times. This is fucking hard. Okay, so for 60 minutes divided by 5, we have 12 minutes for 7 people. Then for each people, then we're gonna have 12 minutes per 7 people. Then if we want 1 people, oh my god, this is insane. What kind of conversion should I use for this? I think I'm not even supposed to do that. Let's just go multiply this by 7. If it takes 12 minutes for 7 people, then for one guy it would be 12 times 7. 14, 1, 7, 84 minutes per person. And then how many minutes does it take 10 people to paint 10 walls? Okay, so if one person can take it's gonna be 84 minutes. Please be correct. If I'm wrong about this, I don't care. I don't want learning this shit again. Oh wow, cool, I'm correct. Let's see how this was answered. Okay, so this was one of the videos. I don't even know the fucking formula for this. So let's first figure out the distance. So Emily traveled uphill to the hardware store for 60 minutes at just 6 miles per second. Per hour. 6 miles per hour. So let's see. Distance is equals to our speed divided by time. So we have 6 MP miles per hour. So divided by 60 minutes. I'm supposed to just cancel like that? That didn't work. DST. Speed times time. Yo, this is insane. Okay. Oh, of course. If I like multiply this by t, it cancels, and so we have r. Okay. Dude, I'm so bad at this. I have 60 miles times 6, 360. But how about the cancellation stuff? This is in minutes. Yo, this is hard, man. So let's figure these things. So this one will be like speed times time, right? So we have 60 minutes, miles per hour. Oh my god, I have to do some conversion stuff. Minutes. Let's do that first. Let's see. 6 miles per hour. Same shit as no. Oh, this actually is in R as well. That's 6 miles, right? Six times 6 divided by 60. Let's see. Why am I converting this when I could do it the other way? I'm supposed to do the 60. This is fucking up my brain, dude. The Asian question. Why does it have squirrels in it? Yo, I'm so excited. I'm just gonna grab some drink. Right, cool. I'm back. So I remember Sal solving this. Let's watch that shit again. I think this is this one. Yeah, finding average rate. It's pretty much similar. It's pretty insane though.
Meter, kilometer, my for that is equal to.
No, it's not this one. Speed translation.
Larger number, or should I be getting this? And 30. I'm going to be going 12 times that many hour. use the calculator.
Yo, this is hard.
Right. Start
Alright, so it's
times
this
in
one.
terms of times to the gift store and times coming back. How do I know that? Well, she went at different speeds, so it's going to take her actually she went there much slower than she came back. So it would take her longer to get there than it took her to get back. So let's see which of these we already know. So how do we figure out the distance to the gift store? No point here do they say, hey, the gift store is this far away. But they do tell us, this first sentence right over here, Umama traveled uphill to the
Umaima.
gift store for 45 minutes at just 8 miles at just 8 miles per hour. So we're given a time and we're given a speed, we should be able to figure out a distance.
So I'm pretty sure this is 6 miles distance. So we have 12 distance.
So let's just do a little bit of a side here. We should be able to figure out the distance to the distance. Actually, let me write it this way. Distance to the store. Distance to store will be equal to, and we got to make sure we have our units right. Here they gave it in minutes. Here they have 8 miles per hour. So let's convert this. Let's
see. She didn't. Let's see. Our rate is equals to like distance over time, right? Okay, so that's 60 minutes. Per hour. Oh shit, it's insane. So the first one is 1 hour. Plus, I said, turn back, it's been like 12 miles per hour. Okay. So intuitively this is twice as fast. Oh my god.
convert this into hours. So 45 minutes in hours.
So we have like
So it's
2 and then
45
3.
minutes out of 60 minutes per
So
hour.
12 by
So that's going to give
4.
us 45 sixtieths, divide both by 15. That's the same thing as 3/4. So it's going to be 3/4 hours. 3/4 hours is the time times an average speed of 8 miles per hour times 8 miles per hour. So what is the distance to the store? Well, 3/4 times 8, or you could view it as 3/4 times 8 times 1, is going to be, what's going to be 24 over 4. Let me just write that. That's going to be 24 over 4, which is equal to, did I get, yeah, 24 over 4, which is equal to 6. And units-wise, we're just left with miles. So the distance to the store is 6 miles. 2 times the distance to the gift store. Well, this whole thing is going to be 12 miles. 12 miles is the total distance she traveled. Now, what is the time to the gift store? Well, they already told that to us. They already told us that it's 45 minutes. Now, I want to put everything in hours. I'm assuming that they want our average speed in hours, so I'm going to put everything in hours. So the time to the gift store was 3/4 of an hour. 3/4 hours. And what's the time coming back from the gift store? Well, we know her speed. We know her speed coming back. We already know the distance from the gift store. It's the same as the distance to the gift store. So we can take this distance. We can take 6 miles. That's the distance to the gift store. 6 miles divided by her speed coming back, which is 24 miles per hour. So divided by 24 miles per hour gives us, let's see, we're going to have 6 over 24 is the same thing as 1/4. It's going to be 1/4. And then miles divided by miles per hour is the same thing as miles times hours per mile. The miles cancel out, and you'll have 1/4 of an hour. So it takes her 1/4 of an hour to get back, and that's that.
So 6 and then 12. So it was 6. 1/2.
that fits our intuition. Actually, let me write that in the same green color.
Of course, it's going to twice as fast. It's going to 1.5 hours. So we have 12 over 1.5. Let's see what this is. Oh, it's going to be 8. So hard, fucking shit. Oh, nice. This is pretty easy, cool. Oh my god. That was insanely hard. The first and the third question. I hate it. Okay. I'm gonna take a rest a bit. 5-minute break or something. Okay, I'm back. Okay, cool, let's start. Why do I feel so tired even though it's only 5 p.m. Okay, I'm recording. Hello, voice? Cool. 3 employees each clock a different number of hours worked this week, which implies the highest earnings per hour. So, per hour, so we have like $80 per hour. Can I just use a calculator? Come on, man. So this one's like 12. Uh, 210. 10. It's not enough though. 10.5. Employee C. 450. Oh my god, I can't even write here. 35, we have 1. 35, 10. Wow, this actually could be exactly 13. C. 390, 515, 105, full 13. Employee C. A community center is holding a raffle. The table below shows the number of tickets purchased and total price paid for 3 different people. Who paid the lowest per ticket? Oh my god, I hate that I have to do this every time. Six, 18, 1, 11, 3, 9, 2. Oh shit. 20, 9, 18, 9, 63 or 64, I'd say. So we have the other one, 64. Who paid the lowest? Who paid the lowest? 9 divided by 5. Let's see. 9. 1, 5, 4, 61.8. Okay. And the last one, 45 divided by 8, you have 5. 43, 35, 4, C. Oh shit, I can use a calculator, fucking bitch. Fucking bitch, I can just show calculator. Okay. Then you have scored 1.5 in cases stored. Points per game from the least to greatest. Can I type 1-1? Okay, I must click shit. Oh, that's 20 points. Let's write some shit. Okay, so clear that shit out. So 154 divided by 19.5. And for the last one, 2 to 7. Wow, okay. So Daniela scored the most. Pope's list. Table shows the details of 3 different river rafting adventures. Which river rafting offers the lowest average speed? Oh my god. So we have wait, what? How am I supposed to know which to divide? If I do like 14 divided by 4, that's 3.5. If I do 5 divided by 2.5, 3 divided, so it's a B soon. You might need calculator. Let's start the quiz. Oh my god. But 5 questions, okay, cool. A box of cookies costs now. What is the cost for 1 cookie? Okay, so we just have to divide 15 by 9. So here we have 9, 60. Wait, what? Is this even right? Oh, let's start. Let's see. A box of 15 costs $9. What is the cost for 1 cookie? Okay, it's actually incorrect. Box of cookies costs 19, so we have 9 actually divided by 15. Should be the other way around. 0, we get 90. Let's see. 15 times 4 is 60, times 6 would be 90, I guess. 6. Since it's a quiz, I can't afford to make a dumb shit mistake. So 30 be 9. Okay, cool. Yeah. 6. It takes for oh shit, I hate this bullshit. It takes 46 more. Okay, let's see. 46 for 10 people to paint 3 walls. For one guy. Let's see. If you divide that by 3, you can't even divide this by 3. What the fuck? 46 is not divisible by 3. It's 10. No, what the fuck? This is hard. Oh, let's just say 46 divided by 10, we have 4.6. I mean, I guess we could have decimal. Let's try it anyway. 46 divided by 3, we have 1. We have 1, 16. Now we have 5, 15, 1, 11, 3, 9, 20, and we have 9. Shit. Can I use calculator, please? Why you no offer me calculator? One, 3, 1, 16, 5, 15, 1, 10. Point 3, 9. Okay, same shit's gonna happen. It's correct. 16 minus 1, 3 out of 10. 15, 9, 1, 10. Okay. 15.3333. Oh my god. God, decimal bullshit. I'm gonna make a mistake here. Now let's, if we divide 46 by 10, we have 4.6 minutes per wall. Not really. 4.6, that make 3 walls. So one wall would be 4.6 times 3. 18, 12, 13.8 minutes per wall. And it would take 10. Well, let's try this again. Let's try this whole shit. Okay, so 4.6 minutes. Why did I divide this by? Oh my god. Let's do it again. That's for 10 people, right? So if it's just 1 people, then it would be 460 in 3 walls. So then if this is 3 wall, multiply it by that. Yeah, if it's just 1 people, it would take times 10 of that, around 60 minutes to paint 3 walls. Okay, so if we divide it by 3, 1. Oh, I've done this shit before. I've done this shit before. Yo. Say 160. Then how many minutes does it take for 4 people to paint 6 walls? Okay, so this is for 1 guy. We would need 160 minutes. So if there are 6 walls, no, there's actually 160 minutes to finish 1 wall for 10 people. So 160 times 6, 0, 6, 36, 6, 9, and then that 960 divided by 4. So we get like 2, 8, 1, 6, 4. Yeah, I think 240 minutes. Oh shit. I don't know, I could be wrong. This is so bullshit. This is so bullshit. Extremely bullshit question. I hate this question. So bullshit. Let's think about this again. If it takes 4 to 6 minutes for 10 people to paint 3 walls, what if it's just 1 person, then it's gonna be 460, right? To paint 3 walls. So if we divide that by 3, which isn't divisible by 3 though, it doesn't go well. It's gonna have fucking infinite decimal bullshit. Oh my god, this is insanely hard, but 240 is my bet. It's not correct because... Oh, actually it could be. I don't know. Let's try the other way around. With 460 divided by 3. So that would be 1, 3, 1, 16, 5, 15, 1, 10. We get 3. Oh, it's actual 3, not 9. Oh my god. 3, 9, 1, 10, 3. So we have like 15.3. Can I just write this as 15 and like 3, 10 like that? No, that's 30. Oh, actually, 15 1/3. I think this would be a much more better angle. Okay, so let's see. So we have 15 1/3. 1/3 is 0.3, right? Okay. And then if it's 10 people, then it's gonna be like times 10 of that. So let's convert the shit. So 45, 46, then 460. Oh, so that's pretty 460. The fuck. Let's do it again. So again. Say 15 1/3. Then of course there's 50. Then for 10 people. Okay. So we have 15.10 minutes to finish per one wall. Okay, 10 people, one wall. 15 minutes. That. Then if you multiply it by 10, then it's gonna be per person. So 46, 30, 45, 40. So we have 460 over 3. Oh my god, 4 3s. Holy shit, we just came to this shit again. Oh, insane. This is insane, bro. This is insane. I don't like it. 3, 1, 6, 15, 1, 10. 3, 9. We got 1, 10. We have remainder 1. So 153 1/3. So 1/3 supposed to be real. Not by 3. Yeah. Say 1/3 left. Okay. So if it takes one, we can do 153. And 1 times 6. Oh, actually I don't need. So let's try. Can we simplify this first? No, I actually can't. Let's see. Let's go 460 over 3. No, it's 150. Over 6 walls. No, let's just do it anyway. Times 6. 6, 1. Then, oh, we could just do this. 460 times 6, 0, 6, 3, 24, 2,700 over 3. And then we're going to divide it by 4. By 4 would be the same thing as multiplying it by its reciprocal. So we have 270 over 12. Let's see what that. Let's get some space over here. 27 over 12, 224, 330, 224, 6, 5. Wow, 2 to 5. This is insane, bro. This is insane. Oh my god, I don't want to make a mistake. Okay, so I got 240 in my first answer, and then I'll have 225. Let's see how many minutes for one wall and one person. Let's do it again for the last time. 46 divided by 3, that's 15. Or we can just say 4 to 6 thirds. And then multiply it by 10. So 460. 4. So we have 460 over 3 would be per wall, minute per wall. One person, minutes, one wall. So if we do, this makes sense, right? Divide by 3, then by 10. 46 minutes divided by 3 minutes. One person per one wall. So if you have 6 walls for that, so 460 over 3 times 6, then divide by 4, which is the same thing multiplied by 1/4. We could, let's see, we could cancel the shit out. We have 1, and then 2, and then we could cancel the shit out again. We have 1 and 2. And then just divide 460 by 2 and get 230, and it gets 225 here. What the fuck? What the fuck? What the fuck? Now divide by 3, get 1. Maybe we're not supposed to do that if this was already like cancelled and shit. I know, let's try again. So you have 460 over 3 times 6 over 1 times 1/4, right? So let's see, you can get rid of this, divide by 3, get 1, and get 2 over here. I guess divide by 4, I guess we can divide by 4, we get 1. And 460 divided by 4, 115. Right? 115. Multiply it by 2, we get 10. 2, 3, 230. Yeah. 230 it is. Ah, so good. That feels so good. That feels so good. Oh crap. I think I can die now. But we have to keep going. A baseball team has 3 different pitchers. Randy pitched 3 innings. What the hell is that? I don't know anything about baseball. Holy shit, this innings and runs. What the fuck is this? Runs allowed per inning. Runs per inning. Okay, so let's show calculator. So you want me runs per innings. Runs per innings. So 3 divided by 2. We have 1.5 there. Felix. 4 divided by 2. I get 0.8 for you. And 5 runs. 5 by 7. 0.71. The lowest number can be Johan. Correct, right? 47 divided by 5. 1.4. Runs 5. Let's see again. 5. 5. Oh shit, okay. Randy could be... Did I do 3 divided by 2 earlier? Oh, wrong. We have 2 per 3. Okay, so it's Randy. Should be Randy, right? Let's do Felix as well. 4 divided by 5. Okay, if this is wrong, I'm gonna kill myself. Cool, that's correct. Starting at home. Ishan. Wow, that's me. Traveled up to the gift store for 18 minutes. It's just 10 miles per hour. Then you traveled back home along the same path down. Like, speed of 30 miles. What's the average speed per strand? Oh shit. So DST. So we're solving for that, for the average speed. So let's first figure out this distance. 18 minutes. Oh, it's 18 over 60. Why can't you give me a fucking calculator for this one? At 10 miles per hour. Point 3 hours. Yo, this is incorrect. It's supposed to be like 60 over and then 18 here. Minutes. No, not really. Wow, I'm so confused. Now let's convert that shit first. Per hour, 18 minutes. So we have 0, 180, 3. Okay, so we have 3 times 10, we have 30 miles. So twice of that, of 60 miles our distance. Then our speed, it's 18 minutes, so we already have 0.3 r plus same path down of speed of 30 miles per hour. So time would be distance divided by speed. So we have 60 miles divided by 30 miles per hour. So it's gonna be like 60 2 hours. What the fuck? For real? Yo, that is much more quicker. Why am I getting 2 hours? This is insane. DST. DST. Oh my god, this is so stupid. Because it's not, it's halfway, it's actually 30. So we have time is equals 30 divided by 30, which is 1 r. Why is it much more longer though? Then this one was actually so much fucking slow. Could be, I could be wrong with the distance here. So 18 minutes, it's 0.3 hours, and distance is speed times time. 30 same units are, so we're gonna have 30 miles, yo. Then twice of that, since going back and forth, get 60. Now this doesn't add up. This doesn't add up. D S D. Let's try this again. So we have 18 minutes. And let's convert that to an R. So one R. We have 60 minutes. Then multiply it by 10 miles per hour. So this shit dies, and oh my god, I just confused my shit again. So this is minutes, this is miles. Let's make MI. Okay, so we have 18, 180 divided by 60. We have 3 miles. So we actually only have 3 miles. So how the fuck did I get like 30 earlier? So I know this 0.3. Oh shit. Yeah, if it's 0.3, then it should be like, oh my god. Whatever. Now we got, it's just sort of blowing my mind. So let's do 10 times 0, 3, it's 0.3, right? So that's blowing my mind. Okay, whatever. So okay, so we have 6 at the top, and then how many is this? 0.3 plus we're looking for the time, which would be distance 3 divided by s 30 miles per hour. So we have 3 divided by 30. It's pretty insane. So 0.1. Oh, this makes much more sense. So we have over 6. About 0.4 actually. 0.4. So what is this? 60 divided by 4. Uh, 1 4 20 5 60 divided by 4 is 15. Is it correct? I mean, it should be bigger, right? So, just need 15. Should be correct. Oh, cool. Yeah, we kind of did that. Okay. Damn, I hate this kind of questions. Baker decorates 42 cupcakes in 30 minutes. Per minute. So we have 42 divided by 30. If I mess it up, I'm gonna kill myself. 120. 120. It's full. 1.4 cupcakes per minute. Okay, let's see. A baker decorates 42 cupcakes in 30 minutes. You decorate cupcakes. How many cupcakes can the baker decorate per minute? So we do really have 42 divided by 30, right? Per minute. Okay, let's just try it again. 1.4, cool. This is so hard, man. How long have I been recording? 2 hours. Okay, let's go this. You should take a break. Yeah, oh my god, this is insane. So I'm gonna take a break. So, wow, this actually took me 2 hours. Insane. Pretty slow, pretty slow. But yeah, they're pretty hard and I really need to like understand what's happening behind. So, how much percent did I get? Shit, I'm 22. I need to make more parts. Let's see. Stayed still. Wow, didn't even gain percent. Okay. Okay, so for now, this is the second quiz, and I'm gonna take a break, and then I'm gonna make another part for this part 16. So part 17 will be continuation. It's pretty long. Wow, took me actually 2 hours and a half. It's pretty insane just for this just for the second quiz. Yeah. So yeah, for the third part, I'm gonna continue this, and hopefully I could continue. Although, whoa, it's a lot. Wow. Okay. All right. Okay. Bye.